let's look at the function p of x. At this stage, it doesn't look like a function, but we're going to use that broken lines now to construct our function. First of all, we see h of x, which is this broken lines here representing a shifted parabola, but it's defined only for x less than or equal to 1. If we zoom in a little bit on the graph, we will see that -1 starts here, and we said that it is less than -1, so we will have an open dot here at -1. I'm going to use a red for that, an open dot, and then it will continue on the path of this broken line of the parabola, and that will be my first part of the function. The next part is already drawn from A to B, and the next part, so this is now h, we've got a h there, and then here g of x is this whole graph, but it's only starting at 1. So it's got an open dot there, and then continues on this broken line in the shape of a semicircle until it reaches the point 5. So there's a closed dot there. So if we now do a vertical line test on this graph, ignoring the broken lines, then you'll see that we are again dealing with a function, because here at -1, that is an open dot, and that's why we draw it bigger so that we can see there's a hole, and then this is included, and then that's included, but that's excluded. So if I do the vertical line test for functions, this will only cut this image once for in each instance. Okay, so let us look at the domain and the range. First of all, as I say, we can look at the restrictions just as the restrictions. So we see, if we look at domain of the first part, domain of h, then it starts at -infinity up to -1. So this is wrong here. So it starts at -infinity up to -1. Combined with close interval -1 to 1, and union with open bracket 1 up to 5, and 5 is a closed bracket. So if we then write down the final answer, then we see that will be from -infinity up to 5, and 5 is included. So we can use all the values, because this dot here covers for that open dot there, this dot covers for that open dot there. So we have each and every x value up to the number 5. If we look at the range, then again we consider the horizontal line test, the horizontal line. So the first time we meet the graph is here at 0. So from 0 we can move up with this function. The highest it can reach is there. This one, the highest it can reach is there. And this function goes up and up and up until infinity. So we can just write down the final answer, which is from 0 up to plus infinity. If we break it down, the red one will be from 0 to infinity. The next one will be from 0 to 1, closed intervals. And the next one will be the center of that. It will be approximately 3, because it's, it will be 3. So it's from CY, I say 3. You can work it out, because if you look at the center, if you take the center of this line, then you will find it happens at 2, and the value at 2 is equal to 3. So there is the maximum value here. So the last one has a domain from 0 is included, and in this case 3 is also included because it's on the line. It's not this dot that we're concerning the maximum value. It's the last time that the graph will leave, the horizontal line will leave the graph. So the range is then that, and the smallest value here is 0, and the largest value is infinity, and that is the final answer. Let us look at the function r of x. If we do a vertical line test, we see that because it's just semicircles and a straight line, the vertical line will cut this image just once for each x value. So each x value only has one y value. So this is a function, but if I look at the domain of each individual part, if I look at the domain of Q, I see it is from -9 up to -3, union, the next one is P, it starts at -2, and it ends at 2. Now you will notice that I have an open dot there, but I have an equal sign there, so we must just change that to less than 2, otherwise it is not correct. And then the last part is union with, from 3 onwards to infinity. So it's an open interval 3 up to infinity. In this case, because of all the gaps in between, because of that gap there from -3 to 2 and from 2 to 3, we cannot write it differently. There are other ways, but this is perhaps the easiest to represent it. Okay, let us look at the range. If I look at the range of Q, the semicircle, it will have its minimum here at a -6, which is -3. So it will start at -3 up to 0. That's on the x-axis. And then the next part will be from 0 up to 2. And the 0, because of that 0, will include that open dot, doesn't matter, because I have to have a 0 up to 2, and then it covers for all that values there. And then the next part here we have a descending function again. So the maximum there is at 4, but it doesn't reach 4, but then it continues down to -infinity. So we will write the first value as -infinity, and then it goes up to 4, but 4 is not included. And in this case, the function I here will cover for all the y values that's in here. So I can conclude and write that the range will be from -infinity to 4. Although the individual parts are smaller, it is contained, because here the moment we start there, it already gives us the values from there to there, and if we continue further on, we get these values. So we only have from negative infinity to 4. Just remind yourself that when I deal with negative infinity, it's smaller than 4. Although negative infinity is a very large number, it's a negative value.